Hi friends, welcome to my channel. In this video, I am going to explain the first algorithm of transportation problem of finding initial basic feasible solution. In my previous videos, you may have seen what the process of transportation algorithm and the steps in transportation algorithm. In this video, I'm taking one example of finding out initial basic feasible solution of transportation problem by using northwest corner cell method. It is the basic method of finding IBFS. Let's see how it works. The company has got 3 sources, and again company has got 4 destinations. These are the markets. D1, D2, D3, D4 are the markets. S1, S2, S3 are sources, warehouses are supply points. S1 having a capacity of 7 units, S2 9 units, S3 18 units. Together it is 34. After D1 having a requirement of 5 units, these are the demand requirements, these are the supply. 5 units, 8 units, 7 units, 14 units respectively, together 34. I have 34 supply and 34 demand. So it is a balanced transportation problem. How do we do with an unbalanced transportation problem? We see in a separate video. Now, it met the condition that it is a balanced transportation problem. We see. The northwest corner cell method is only position specific. We have these north, west, east and south. What is a cell which is in the northwest corner? That means the first, take it as a table, that means the first cell of the table is very important here. The first cell of the table is this one. The first cell of the table is this. S1, D1. Let me explain about S1, D1. S1 having a capacity of 7 units. D1 having a requirement of 5 units. So it is possible to transfer required units from S1 to D1. Now this 19 means the cost of transporting one single unit from S1 to D1. So we see this allocation process. D1 required 5 units, but S1 can transport 7 units. So what I do? I assign these 5 units. After assigning 5 units, this D1 requirements get 0 because it fulfill through S1. Now this S1, after allocating 5 units, right now the capacity of S1 will becomes as 2. 7 minus 5, 2. So what happened here? It becomes 0. D1 is completed. Right now I have to think about D1. D1 need 5 units. I sunded it. I allocated that 5 units. So it is finished. No need of thinking about D1 again. Now with this, for my conveniences, I am deleting this from the table. Next, first cell of the table, again northwest cell. The next northwest cell of the table will becomes this D2. S1, D2, because D1 column completed, exhausted, completed. Now D2, S1, D2. Here S1 having a capacity of 2 units and a requirement of 8 units. I need 8, but I can take 2 units from S1 only. So I am doing the same. 2 by this it becomes 0 and by this it becomes 6. Is D2 completed? No. D2 need 8 units. In that I assign 2 units only. But S1 exhausted. S1 completed. So again take off this row from the table. Now the next first cell of the table again becomes this S2 D2. Here the situation is 9 and 6. So I am assigning 6 units here. So this completed and this becomes 3. Now this is 0. So delete this one also. The next first cell of the table will be this S2 D3. 7 and 3. So I am allocating 3 units here. This becomes 0 and this becomes 4. 0. So you have to eliminate this from the table. Right now again the first cell, next first cell of the table will becomes on the northwest cell. This is this S3 D3. 4 and 18. Here I can able to assign 4. So this becomes 0 and this becomes 14. 0 you see. So eliminate this. And after here the last cell of the table I reached, I started here S1 D1. Now I am reached to S3 D4. So here 14 and 14. So I am able to assign 14 here. So 14, 0 and 0. That's it. So I assign all of my available supply to all of my requirements. 0, 0, 0, 0, 0, 0, 0 and completed. 34 units are allocated. Now find out the transportation cost. That equal to 19 into 5 plus next allocation 30 into 2 plus 30 into 6 plus 40 into 3 70 into 4 plus 20 into 14. By finding out all, it would be 1050. My total transportation cost of transporting these 34 units from 3 sources to the 4 destinations by using north-west corner cell method is 1050. This is initial basic feasible solution by NWCC. Now after this we find out optimality of this solution, whether it is a right or even we can decrease it for more extent. Is the solution is optimum or optimal? That we check the validate the optimality by 2 methods we have: modified distribution method or stepping stone method. We see that in a next video. Thank you. Please subscribe to my channel